Today we're going to be doing third grade worksheet lesson 33. So let's start off with telling if the blue line is a line of symmetry, right? Yes or no. And this paragraph here gives a brief description of figures and um how they would classify if they had lines of symmetry. And it says a figure has symmetry if it can be folded along the line so that the two parts match exactly. So basically that the blue line dividing the figure, the two sides would need to be exactly the same for them to have a lines of symmetry. So like number one, the left side here and the right side they match exactly, which means if you fold them, then they would perfectly fold on top of each other. So number one is yes. Number two, we can see here that the outline of the figure on the top that the blue line's dividing is like this, but the bottom is like this. So if you look at these two shapes, they're not the same. So number two is no. And number three, um, it's if you fold the two figures, then they would perfectly align with each other. So it is yes. Number four, a circle with a smiley face is also a line of symmetry. The blue line is a line of symmetry because the the two halves are exactly the same. Like there's one eye on each side and there's half a smile. So it's yes. Number five. So if we were to fold this over this, then there would be this part not aligning with this part over here. So number five is no. Number six, these two halves are exactly the same. So yes. Okay, so a plane figure can be moved in different ways. Tell what kind of motion was used to move each plane figure. Right, slide, flip, or turn. So slide is a change in a shift in the figure. A flip is just it flips it, and a turn is it just changes the direction 180 degrees. Okay, number one. So we can see here that this figure has it goes the opposite direction, and it looks pretty similar to the turn one here. So number one is turn. Number two. So the original figure was probably like just a diamond. And then they flipped it so that once it's divided, it would be flipped. So number two is flip. Also, we can tell here because also in the description of flip, there's a line dividing the two halves. No, not the two halves, the two figures, and it's changed. Now, number three, the figure slide from here to here, and we can tell because there's an arrow. So number three would be slide. Same thing, this would be slide. And number five. So once it was like this, the block was flipped to go like this, and they just placed it here. So number five, flip, and oh, not flip, sorry, turn, because it's going the opposite direction 180 degrees. And number six, like we said before, the line dividing it means it's a flip. Now moving on to tessellations. Tell if each figure will tessellate. Right? Yes or no. Okay, so the description of a tessellation. When plane figures combine to cover a surface without overlapping or leaving any space between them, those figures tessellate. Okay, so number one. let's just do it as if it does tessellate. So let's draw an oval here. And if we want to draw an oval in between the two ovals and on the top without it overlapping, we would have to place it like so. But then there would be a gap here, which means it doesn't tessellate. So number one, no. Okay, number two, we can continuously just place rectangles on top and on the side of each other, and they would tessellate. So number two is yes. Number three, same thing. If we just keep doing this, then there wouldn't be any overlapping spaces or any gaps. So number three would also work. Now, number four, pentagons. Pentagons don't they're a specific figure that don't tessellate because each interior angle adds up to 180 degrees. And in total, there are 360 degrees in just a figure. So if you would divide the two numbers, then it wouldn't be a whole number, it'd be a decimal. So that means there'd be some space that would be overlapping or a gap. So number four would be no. Number five, a triangle. Triangles would because you can just draw it as so, and there would always be a triangle to fill in the gap. Yes. So hexagons. Unlike pentagons, when you divide the interior angles by 360, they would be a whole number, so yes. And number seven, which is a circle, it's the same thing as an oval. If we were to try to do it, try to draw repeating patterns of a circle, then there would just be a gap here. That would mean it wouldn't be. And number eight is the same thing as number three, so yes. Okay, word problems. Pilar says that a pentagon is a tessellate. Do you agree or disagree? So, like I was mentioning before, angle of pentagon over angle of whole figure. Now, the angle of a pentagon is 133 degrees, and the angle of a whole figure is 360. No, angle of each angle, each angle of pentagon. So when you would divide it, it wouldn't be it would be a decimal. It would be 1 point something something something. So that means that the angles wouldn't be perfectly aligned with each other. So I agree. And that's all we're going to do for today.